For those that are absent, if you are not in class when we take the quiz, I want to make sure you still have access to my review so that you are feeling more comfortable when you sit down in Delta Math to take your quiz. So here's the problems that I'm planning on going over in class. So first, I want to just talk some description a little bit. So we are faced with a few polynomials here. It's going to ask you different characteristics of the polynomials. So first, it's going to ask about the degree. So your degree is your highest exponent. So in this first one, your degree is 5, and your next one, your degree is 4. Always make sure you do check first that it's in standard form, meaning that your terms go from highest exponent to lowest exponent, because you don't want to accidentally say the first exponent you see when the terms are out of order. The next thing we'll ask about your leading coefficient and your leading term. And it depends on the question in Delta Math which one they want. So I want to mention both. Your leading coefficient is just the number that is in front of your first term. So in case this first one, the number would just be a 1 because there's 1x to the 5th. In this one, your leading coefficient would be a -2. The leading term wants the entire term, not just the number in front. So if it asks for leading term, you're going to put the entire x to the 5th. And for this one, you're going to put the entire -2x to the 4th. And again, you just have to read carefully and see which one do they want. Coefficient meaning just the number, term meaning the entire term. For types, and I put types with an S plural because there are two ways to describe every polynomial. One is by the degree and one is by the number of terms. So your degree, your words for degree were linear, quadratic, cubic, quartic, quintic, and that's as high as I asked you to go. So 5th degree, this is a quintic. The one to the right, 4th degree, this is a quartic. The prefix quar, like quarters in a football game, meaning 4. And then your terms, you're going to count your terms. You have monomials, binomials, trinomials, and then after that, we just call them polynomials of 4 terms or 5 terms. We don't have any fancy names after that. These are both trinomials because they both have 3 terms. Trinomial. So you will be asked some questions about the description or the classification. Finally, end behavior. So end behavior is asking what does it do to the far left and to the far right. You are welcome to draw pictures or to graph things on your calculator, and there will be ones on Delta Math that it's actually drawn on the screen for you. If you can also use the chart that we did in class. So if it is odd, so if it has an odd degree, we know the end behavior is opposite, meaning one side's going to go up and one side's going to go down. If it's odd with a positive leading coefficient, I'm just going to kind of draw a little picture of what you'd see on your calculator. The left side is going to be heading down, the right side is going to be heading up. So the way that we write that is as x goes to -infinity, that's the left, my function or my y value is going down, so that's -infinity. And as I go to the right, which is as x goes to +infinity, my function or my y value is going up towards +infinity. If it is an even power, so your even powers are, I think the even powers are easier because the end behavior is the same on both ends. It's either going up on both ends or down. It will be determined by your leading number. So if it's negative, you want to think of it like this. I'm just going to draw something really simple. I know the actual graph is a little more complicated. It is going to go down on both sides. So the way that we write that is as we go to -infinity, my function will go down to -infinity. And as x goes to +infinity, which means the right side, my function will continue to go down. So it goes down on both ends. The f values are going to be what tells you if it goes up or down. Your x's are the talking right versus left. I pulled all these from Delta Math just so I could have a little discussion about them. So the first one, I want to talk about the difference between increasing and decreasing, positive and negative. We had this conversation in class. So increasing means on its way up. So this graph is increasing from, make a little note here, from -infinity until it gets to B, because it's going, thinking like riding a roller coaster, it's going up. Then from B to D, it switches to going downward, so it's decreasing. Again, you're going down the roller coaster. So from B to D. And then from D on, we're back to increasing. So we're increasing again from D to infinity. As far as positive versus negative, I like to kind of mark it like this. Positive means it's above the x-axis, so my function has a positive y value. Negative means it's below. So I am positive from A to C, and I'm positive again from E to infinity. Those are all the intervals where my graph is above the x-axis, and I am negative when it's below the x-axis, which is negative infinity to A and C to E. So they're going to ask you questions to either write intervals or to describe intervals. I think this particular question said something like, tell me what's happening from A to B. Well, from A to B, it's increasing, and from A to B, it's also positive. So you're looking at just like a single interval with those. If you look at the question to the right, this is the end behavior one that I was talking about. So you'll notice on the left side, it's going up, and on the right side, it's going down. So we're looking for the choice that says as x goes to negative infinity, it's going up. So this is the negative infinity ones. At negative infinity, it's going up. So that's either this one or this one. And as we go to positive infinity, it's going down. So the correct answer here is this one. And then finally, the last picture, this is a series of drop-down questions on your Delta Math assignment. It will ask the degree, and when it asks the degree, it doesn't need you, it's not going to ask you to say a number, it's going to ask you to say if it's even or odd. So you're going to look at the end behavior. If the end behavior is both going in the same direction, like this one, it is even. If the end behavior is doing one of each, so like this one over here, it's odd. So this one we would say is an even degree. So that's my first drop-down. My leading coefficient, so if it's up in both directions, it's going to have a positive leading coefficient. If it's down in both directions, it's going to be negative. If it's odd, you're going to have to check and see which side's up and which side's down. Or you could just graph something, try like x to the third in your calculator, try negative x to the third in your calculator. Real zeros means how many times does it cross or touch the x-axis? So 1, 2, 3 times. So it has 3 zeros. And then your minimums. So it might ask for minimums. It might ask for maximums. It may ask for what's called extreme, which is all of your minimums and maximums. So it has a minimum. I'm going to put them in red. It's got a minimum right here. And it's got a minimum right here. So this one has 2 minimums. So those are the visual type questions you'll see on Delta Math. Moving on. Here's one more visual question. So these are also pretty quick. This is a matching. You definitely can use a calculator if you need it, but I think we can kind of get away with not needing it. So we have a 0 at -7, which means x plus 7 has got to be a factor. So it's not the one with the -7, not the one with -7. And then we have 2 as being a solution. Since it just touches it there, we would say that it repeats, meaning it's there more than once. So we are looking for the one that has an x minus 2 and another x minus 2, and that is choice, in this case, A, I guess I would call it the very first one. So another visual one. This is something else we did in 5.1. We called it finite differences. We had to figure out what degree your polynomial would be based on checking the difference between terms. So you're going to subtract your y minus your y next to it. So you do this one minus this one, or you could do it in your head. So let's see, to go from 77 to 24, we go down 53. To go from 24 to 1, we go down 23. To go from 1 to -4, we go down 5. To go from 4 to -3, we go up 1. -3 to -8, we go down 5. And -8 to -31, we go down 23. Obviously, those numbers are not all the same, so we continue. So to go from -53 to -23, we're going to go up 30. To go from -23 to -5, we're going to go up 18. To go from -5 to 1, we're going to go up 6. 1 to 5, -5, excuse me, we're going to go down 6. And -5 to -23, we're going to go down 18. Still not the same, so we keep going. This is 30 to 18 is down 12. 18 to 6 is also down 12. This is looking good. 6 to -6 is still down 12. And -6 to -18 is still down 12. So you want to count how many times it took to go through this process. That is your degree. So we would say it's a third degree. And that means that your type, just kind of reviewing those words, third degree is referred to as a cubic function. So that was finite differences. And that's pretty much the end of 5.1. We did a lot of description in 5.1, a lot of visual and classification type questions. 5.2, we looked at ones where you would be given the solutions and you had to write the actual equation. So for something like this, you're going to take each solution and write it as a factor that goes with it. So -4 would be x plus 4, 4 would be x minus 4, and 2 would be x minus 2. You need to pick two of them and multiply them together. So I'm going to FOIL the first two because they're going to be the easiest. So x times x is x squared. My outer and my inner will cancel, so I'm going to skip that. I'm going to go right to my 4 times -4, which is -16. So that's the first two foiled together. And then I'm going to FOIL again. I'm going to multiply. The goal is to get it completely in standard form. So I'm going to multiply x squared times x, which is x to the third, x squared times -2, -16x, and then finally -16 times -2 is +32. This one has three factors. Now the first one's really easy. Since 0 is a solution, you're just going to have an x. 1/3 is going to be 3x minus 1, and 2 is going to be x plus 2. I'm going to leave this x where it is and FOIL the rest of it. So I'm going to FOIL this together. I get 3x squared. My outer is 6x. My inner is -1x. And my last is -2. I'm going to combine like terms. 6x minus 1x is 5x. And then finally, I'm going to multiply everything by x when I'm done. So I get 3x to the third plus 5x to the second minus 2x as my final answer. The biggest thing to keep in mind when you're done, make sure you do have it in standard form. You can write it equal to 0 or equal to y, but make sure you've multiplied it all together. Then we get into the factoring, and this was what we spent a lot of time with on the last couple days this week, is getting things in standard form, factoring using all our different techniques. We now have a big list of techniques, and then writing our solutions. So we're going to get this in standard form by subtracting 12. So I'm going to do this. This one I'm going to get in standard form by adding 8. And that one's already in standard form, so that one's good. So the first one, I have 3 terms. I have no GCF. This is a basic FOIL factor. I need numbers that multiply to get -12 and add to get 4. That would be -6, +6 and -2. Anything that is x squared plus a number will not factor, and this will give me only imaginary solutions. So I'm just going to make a little note on that. This one, I actually will get solutions. If I set that equal to 0, I'm going to add 2 to both sides, and then I'm going to take the square root of both sides. So my two solutions are plus and minus √2. And if you graph this on your calculator, you will see 2 places that it crosses the axis. So your picture should match your work. The next one, we can take an 8 out. It does have a GCF, and that's going to make it a little bit easier for us. So we're left with 8x cubed plus 1. This is a sum of cubes. So I'm going to come off to the side and write down my a and my b value. Anytime you have 2 terms where everything is a perfect cube, the power is a perfect cube, the numbers are perfect cubes, you're going to write down your a and b and use that formula. So a is going to be 2x because that's what was cubed to get 8x cubed, and b is going to be 1. So my formula is a plus b, so 2x plus 1, a squared, which is 4x squared, minus a times b, which is minus 2x plus 1. As far as solutions, I'm pretty sure on Delta Math, it only wants you to factor, so you would leave your answer like this. For solutions, the only solution you're going to get is from this first parentheses. You're going to get -1/2 because this is going to be imaginary. And this doesn't have an x, so there's no solutions there. And then finally, the last one here, this is grouping, factoring by grouping, and I know that immediately because it has 4 terms, and I can only do grouping with 4 terms. It's my only technique. So I'm going to break it up into my 2 groups. I'm going to take x squared out of my first 2, which leaves me with x plus 2. And then I'm going to take a 5 out of the next 2, which also leaves me with x plus 2. I'm going to pull this to the front, the x plus 2. And then I'm going to be left with x squared plus 5. As far as solutions, again, this is just imaginary because it's x squared plus something. You do get a solution from the first one, and it is -2. If it only asks you to factor, please just leave it like this. You're only going to list solutions if it actually wants you to write your solutions or write your zeros. I've got a few more. Keep going with this. So x to the 4th plus 7x squared minus 18. This breaks down. This is a basic FOIL factor, x squared and x squared. I need numbers that multiply to get -18 and add to get 7. That's +9 and -2. This will not go any further because it's an addition. This one, I actually just did this one earlier. You get plus or minus the square root of 2. The next one, you can take an x out first, which leaves you with x squared minus 9x minus 22. I need two numbers that multiply to get negative 22 and add to get negative 9. So that's negative 11 and positive 2. My solutions, again, 0, 11, and negative 2, one from each of these. And again, I'm keep reminding you, if it only says factor, because I think most of the quiz is actually going to be factor only, please leave it like this. If it asks for solutions, that's when you write these answers. Last one, I'm going to get in standard form. So I'm going to bring over the x. So I'm going to add x to both sides, and I'm going to bring over the 5 by subtracting it. This is a grouping because it has 4 terms. So I'm going to pull out the x squared, which leaves me with x squared minus 5. Oh, wait, shoot. Sorry, I'm going to bring out an x to the third, which leaves me with x minus 5. Wrote it wrong. And then I'm going to bring out a 1. So if they have nothing in common, they have no GCF, you have to have something come out. So your GCF is truly just a 1. So I'm going to pull this to the front. And then I'm left with x cubed plus 1. X cubed plus 1 is another perfect cube. So I need to do an A and a B here. A is x, B is 1. So I get a plus b, x plus 1, a squared minus ab plus b squared. I do have two solutions. 5 makes the first factor 0, negative 1 makes the second factor equal to 0, and this again is imaginary. Last thing I want to do to review is make sure you guys are comfortable with your calculator. So make sure you have your calculator close by as I'm explaining this. I am going to get it in standard form. I'm going to do a little bit of work before I go to my calculator. First thing I'm going to do is get everything equal to 0. And then one thing I notice is everything has an x squared in it. So I'm going to pull an x squared out, and that's just going to make it easier to type in my calculator. So I'm going to go to my calculator, and I'm going to go to y equals. Get rid of whatever you have in there from a previous problem. I'm just going to type in this part. I know what makes this equal to 0. I know I get 0 as an answer, but I don't know what makes the other equal to 0, and that's where my calculator comes in. So I'm going to type in 15x squared minus 11x minus 14. Hit graph. If your graph is kind of goofy with your window, like mine is, if you hit zoom 6, you can go back to a basic window. So there we go. So I have two answers that I'm looking for. They are going to be decimals, and you're going to see this on the quiz as well. So you're going to go to second and trace to the 0 button. And you're going to move your cursor so it's before it crosses the x-axis the first time. There it is. Hit enter. And then go through the x-axis, hit enter, and then enter one more time. And I am going to ask on the quiz that you just go to the nearest 10th, one decimal place. So this would be negative 0.7. And then I'm going to do the same thing for the other ones. Second, trace, 0. I'm going to move my cursor through. I want to be before it crosses the x-axis. Where is it? It's coming. Maybe here it is. Hit enter, then go to the right area a little bit more, hit enter, and enter one more time. You get 1.4. So my solutions are 0, negative 0.7, and 1.4. This video should get you completely ready for that quiz. And now you can go through, obviously use your calculator. You're going to rely on it to check a lot of answers, even if you don't use it a ton for actually doing a lot of graphing like this one. And then make sure you look over everything and complete it when you're done.